Welcome back to Science Fantastic with Professor Michio Kaku. Today on Science Fantastic, we're going to take the larger view of the universe. First of all, we're going to start off with a comet. Maybe you saw that comet whizzing overhead last month, and we'll talk about it with an astronomer who has clear viewing in Arizona. And then, of course, we have not one, not two, but three probes headed toward Mars, the red planet. And maybe sometime in February, one or all three may actually reach their target. Of course, getting off the ground to Mars is the easy part. The hard part is actually a soft landing on the red planet. And then SpaceX made history once again. The United States is back in the astronaut business. After depending upon the Russians for so many years, SpaceX has propelled the influx of money from private enterprise, new energy, new momentum from private enterprise. And then the next question is, what about the moon? And what about a piloted mission to the planet Mars? Well, once again, with us today is astronomer Chris MP. He's Distinguished Professor of Astronomy at the University of Arizona in Tucson, author of a number of great books, including Beyond, Our Future in Space, and How It Began and How It Ends. Well, Chris, glad you could be on once again. Science, fantastic.
Yeah, it's great to talk to you, Michio.
First question for you is the comet that sailed overhead a few weeks ago. In New York City, of course, we have so much light pollution we can't see really anything. But I still remember actually seeing Hale-Bopp. I remember seeing Hale-Bopp sail actually over Broadway.
Wow.
Just by chance, I was able to catch it at the right angle, so I saw the comet hovering over Broadway. But what was it like in Arizona? Did you get a clear shot at the comet?
Yes, we did. Just by the way, Comets Over Broadway sounds like a good title for a musical. Arizona, yes, we have really good skies. I mean, we're in a city, but the lighting ordinances are quite strict. So even in my backyard, it was visible for a while in the evening and for a while in the early morning, and it was impressive. Astronomers are not really able to predict the brightness of comets, even when they know their trajectory, because we don't know what they're made of in detail, and how bright they are depends on the stuff fizzing off them. So this was a good one, better than expected.
And I understand that if you miss it, you can wait another 6,800 years for it to return.
Yeah,
but that means, of course, it probably came from way out there, right?
That's right. It goes into the deep freeze of outer solar system, as do most comets. I mean, most comets are a very long period. Halley's comet was 86-year orbit. Actually, that's on the low side. Most of them are much longer.
And where do they come from? The Oort cloud that some people have been talking about, the Kuiper belt. Where do these comets come from?
Yes, with this Neowise and this very long orbit that takes it way outside the planet's orbits, the Oort cloud is a hypothetical but pretty much confirmed now spherical cloud that extends to 50 to 100,000 astronomical units. You know, that's 1,000 times the distance to Neptune. And there's possibly 1 trillion comets there. That's an estimate, of course, and then they occasionally come to the inner solar system, get lit up by the sun, and we see them. So there's this huge reservoir of comets in the deep freeze, of course, with Kepler's orbit, spending most of their time way out there and very little time in here.
And by the way, I once heard an astronomer talk about a speculative scenario that if a comet were to make its first pass around the sun, it wouldn't have much of a tail at all. But as it whips around the sun and it sprouts a tail, and if it's headed toward the Earth, we wouldn't have much warning. We wouldn't see it because, of course, it has no tail on its first trip around the sun. But as it whips around the sun and it sprouts a tail, we might only have a few weeks, a few months warning before it impacts on the Earth. But is that scenario simply science fiction, or is that possible?
I would say that's a very low probability scenario, but on the other hand, you know, we do have networks of small telescopes looking for moving objects in the solar system, so there are projects that are supposed to pick up asteroids that are heading towards the Earth or comets that are peeking out from behind the sun heading towards us. So I'd say with some confidence we have a network of telescopes that could pick such a thing up, but it's unlikely.
Okay, let's now move on to Mars, where we have not one, not two, but three probes headed toward the red planet. And some people say, well, that's the easy part. Getting off the planet Earth and heading out to Mars, that's the easy part. The hard part is what happens in February when they make a close approach to Mars. So first of all, briefly explain to us the difference between the three probes, one from the United Arab Emirates, one from China, and of course one from NASA.
Right. So this is a cornucopia of Mars missions, and we're in a launch window, of course. Every 2 years we get a window when, with minimum time and energy, you can get to Mars. So they're all clustered, these launches. The NASA mission is Perseverance, and it was delayed 2 years. It was supposed to go during the last launch window, so it's heavily anticipated. It's a really complex, sophisticated rover that's a twin of the Curiosity rover, but with better capabilities. The Chinese, are hitting for the fences, to use a baseball analogy. I mean, they have a very aggressive space program, and they're simultaneously doing an orbiter, a lander, and a rover to Mars, having not been there at all, which is very ambitious. And their mission is called Tianwen-1, which is Questions to Heaven. It's from a classical Chinese poem. And then the third mission, maybe the most surprising to many people, is the Hope orbiter, and it's being launched by the United Arab Emirates, who really haven't done anything in space at all, and now they're going to Mars, which is kind of amazing.
And some people say that the Chinese mission is, of course, not up to par with the United States, but is rather ambitious because it's a 3-in-1 shot. It has an orbiter, a lander, and a rover. And it took the United States, of course, years to progress from an orbiter, a lander, to a rover. And the Chinese wanted to do it in just one shot. So that's rather ambitious, though, right?
Yes, it is ambitious. They're on a fast track with their space program. Their budgets are a little mysterious and opaque because they're twinned with the military-industrial complex, and we don't get to see them. But they're spending a lot on space, and it's a matter of national pride, as you can imagine, for the Chinese to do this. And so, yeah, it's very ambitious, triple shot. Now, the sophistication of the rover itself is not up to the NASA one, I would say. So they tend to, I think some space wags have said that, United States builds Mercedes to go to Mars and the Chinese build a Ford without a lot of bells and whistles, but it's still an impressive achievement if they can do it.
Okay, and let's talk about the Mars mission of NASA, a helicopter. A helicopter, if all goes well, will begin to take off on the surface of Mars. So why do we need a helicopter? I mean, we have rovers that give us close-up pictures of rocks. We have orbiters from hundreds of miles giving us the landscape. So where does a helicopter fit into this?
Yeah, it's very exciting, actually, and people were surprised. A helicopter on Mars, and it was technically very difficult. The helicopter has been named Ingenuity, and it's really a nice middle ground. Orbiters give you that bird's eye, very high view, but not with great detail. The rovers are fine, and they can pick up rocks and analyze rocks, but they can only travel some dozens of miles. The helicopter has a bigger range, and, it can do reconnaissance or sort of scout out future places that you might want to land and store rocks. And the challenge, of course, they had is that the Mars atmosphere is 1/100th as dense as Earth, so all the normal helicopter models and technologies failed miserably in the lab, and they really had to do some clever tricks to get this helicopter to work in such thin atmosphere.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, we have with us astronomer Chris MP, author of a number of great books, including Beyond, Our Future in Space, and also How It Began and How It Ends. And we should say that he's a distinguished professor of astronomy at the University of Arizona in Tucson, where they have a spectacular view of the night sky. Well, we're talking about Mars. Not one, not two, but three missions headed toward the red planet. But NASA's mission has several features that we've never had before. A helicopter that we mentioned that will roam briefly over the surface of Mars, but also rock retrieval. We're going to bring back rocks from the planet Mars. Now, some people who have followed the Mars program know that we already have meteorites from Mars. So how do we know that? How do we know that meteorites have landed on the Earth from Mars?
Yeah, I mean, part of it's just pure geology. So geologists can recognize terrestrial geology and Martian geology is different, as we now know. But I think the clincher for Mars rocks is that there are tiny little inclusions in the meteorites where the Martian atmosphere has been preserved pristine inside the rock. And you can look at the composition of the atmosphere, all the chemistry of it, all the proportion of the elements, and it perfectly matches the Martian atmosphere. So that almost is conclusive that these are Mars rocks.
Now, I once read an article that says that there can actually be a cosmic ping pong game between the planets as meteorites strike Mars or Venus and blow debris into space that drift for millions of years and then land on another planet like the planet Earth. So we might actually have Venusian rock, lunar rock, Martian rocks on the Earth, and Earth rocks on the other planets. So what do you think? Do you think that there could be many pieces of debris ricocheting across the solar system?
Yeah, there's this sort of inefficient conveyor belt that moves rocks between planets after impacts on the planets. But the probabilities of the point-to-point transfer of rock depend on where it's coming from and going to. So Mars to Earth is a highly favorable one because Mars is a low-mass planet, so it takes less energy to blast a rock off and get it through the thin atmosphere. And the Earth is near the sun, the heavy gravity object. So those rocks are quite likely to come in our direction. The reverse direction is less likely. We have a thick atmosphere, more gravity, and the rock will be heading outward. Same for Venus. Venus is a thick atmosphere, so blasting a rock through that would be very difficult. So we don't think there are Venusian rocks. So we're pretty confident of Mars meteorites. There are about 100 that have been cataloged, and there are undoubtedly more. And there are also lunar meteorites, so we know that we've found chunks of the moon that have fallen onto the Earth.
And the rover, Perseverance, is going to store rocks for a later retrieval, perhaps around 2031. So what are we going to learn that we haven't learned before? When we get real rocks from Mars that are perhaps at the bottom of a riverbed, an ancient riverbed, what are we going to learn if we actually bring them back to the planet Earth?
Yeah, I think people wonder because it's a lot of work and it takes a long time to stash rocks and then bring them back with yet another mission in the future. Why does it take so long? Why do we bother? And the simple answer is that as clever and as sophisticated as these little rovers are, there's just a limit to the kind of science they can do. And the big question that, of course, we want to answer is there life on Mars? And we don't think there's present life on Mars on the surface, but there could well be fossilized or microbial remnants of life from billions of years ago. But the rovers can't do those kind of experiments on the rocks. On Earth, we can do them easily. You can look at it, take a rock apart atom by atom. And so having the rock back on Earth increases the sophistication of the ways we can look for previous life forms in the rock by an enormous amount.
Now, you mentioned that we see no forms of life on the surface of Mars, but then what about underground? It's conjectured that underneath the polar ice caps there could be a lake of liquid water. And also, this Perseverance rover is going to have ground-penetrating radar, apparently for the first time. We're going to be able to peer maybe 30 feet underground. So do you think that could open up a whole new landscape, being able to look underground? Because on the surface, we don't see any microbial life forms, but maybe underground. What are your thoughts?
Absolutely. So you're right. That's one of the most exciting of the 7 instruments on the rover is the subsurface radar experiment. So on the polar caps, absolutely, there's frozen carbon dioxide and frozen ice, but we also think there are subsurface aquifers on the mid-latitudes of Mars, the kind of places that Perseverance is going. And so this radar is a technology that could see a subsurface aquifer where there's liquid water right now, and it's protected from the intense cold and the low pressure in the atmosphere by being under rock and under pressure and with heat from within. So that's where we think there could be microbes right now that are living. And the first step to finding them is to find one of these aquifers, and the radar is a tool that might be able to do that. That's, again, a low probability bet because you'd have to get very lucky to find one within the range of this radar at one landing location. But it's very exciting to look.
And I understand that in preparation for one day a manned mission to Mars, they're looking at oxygen separation. That is, taking carbon dioxide, of which there's plenty of it, right?
Mm-hmm.
It's taking out the oxygen and then using that oxygen in the future for breathing, for rocket fuel, or what have you. So this is a new chapter, right? Being able to perhaps harvest some of the existing carbon dioxide to take out the oxygen. What are your thoughts?
Yes, definitely. NASA's been working on this for a while. I visited Kennedy Space Center a while ago, and there's a lab where there's a little, what they call a Mars oxygen plant, and it's just a machine that works with Mars-type rocks, and just through electrochemical means, separates out the oxygen from carbonates and frozen water and frozen carbon dioxide. So it's a good technology. It's not even that sophisticated, and that would be a prototype for a plant that you would put on Mars to generate the oxygen for astronauts to breathe and as you say, to make rocket fuel. And you just use the rocks around you to do it. So that's the way people plan to hopefully make a habitat on Mars, I assume.
Okay, well, Mars visionaries say that we can, quote, live off the land, just like the pioneers lived off the land when they explored the New World. But hey, they didn't have to worry about oxygen. They didn't have to worry about plants. They didn't have to worry about animals. It was already here. Mars has none of the above. So if we can get oxygen separation off the ground, that could really open up a gateway for astronauts, right? They wouldn't have to bring bulky oxygen tanks like scuba divers from Earth to Mars. They could simply harvest the existing carbon dioxide on Mars and, quote, live off the land. What are your thoughts?
That's right. And we have to remember that it's really expensive to send stuff to Mars. So when you send people, you want to send as little with them as possible. And so the staging of the Mars base, say a first version of Mars base, will involve a whole series of missions that are just sending hardware to Mars, the oxygen plant and so on, solar panels, etc. A lot of hardware that the colonists or the astronauts that might want to live there for a while will need to set up and get running. They'll also turn the Martian soil into sort of slump block to cover their habitat with to protect them from cosmic rays and radiation. So again, you can use the soil, the plain old Martian soil, for a lot of useful purposes.
Okay, and of course there's a raging debate even among astronauts about going to Mars. Some say that we should make a trip to Mars in one jump, bypassing the moon. We've been there, we've done it. Why bother to go back to the moon? Other people think the tried and true method is the best, step by step, going to the moon, getting a lunar orbiter off the ground, and then jumping to Mars. What are your thoughts? I understand that Elon Musk is preferring the strategy of a one jump to Mars, but NASA is taking the more tried and true strategy. But do you have any thoughts?
Yeah, I mean, it's generally true that NASA is a little more conservative. They staged their approach. And Elon Musk is a man in a hurry. He said he wants to die on Mars. I mean, hopefully of natural causes, as an old man. But yes, he thinks he can get there in one jump. And NASA could too. NASA doesn't have to go to the moon as a staging post. But, of course, these are difficult things to do at a distance, at 50 million miles away. A lot easier to test things out and these new technologies when you're only 250,000 miles away. So the logic of trying out a lot of these technologies on the moon, where you can also do those same tricks with the soil of getting oxygen out of it.
Back to Science Fantastic with Professor Michio Kaku. Once again, our special guest today is Distinguished Professor Chris Empey. He's Professor of Astronomy at the University of Arizona in Tucson, author of a number of great books, including Beyond, Our Future in Space, and also How It Began and How It Ends. And today we're talking about, well, space. We're talking about Mars, comets, and we're talking about going back to the moon. Well, where we last left off, we were talking about a potential mission to Mars. And some people say that there is a hidden problem that has not really been discussed at length, and that is the danger of radiation. I mean, we are protected by a layer of oxygen and nitrogen in our atmosphere, which protects us from harmful solar rays and cosmic rays. But in deep space, there's no protection. And so the question is, if a voyage to Mars takes 2 years for a round-trip mission, that's a lot of radiation that our astronauts are going to absorb. So what are your thoughts? Is that a major problem, or are there tricks that we can use to get around the question of radiation in outer space?
Well, it's a tough problem because to protect from radiation, you need shielding, and shielding is heavy, and heavy things are expensive to put into space. So, that it goes against the idea of protecting people to keep things under control. So, to put a number on it, that round trip to Mars that you talked about, they estimate it gives you about 3 or 4 times the lifetime radiation exposure you would normally get in that one period of time. And that increases your cancer risk by a few percent, not a huge amount, actually. So there's a risk associated with the trip, but it's not vast, perhaps not vast compared to the risk of doing it at all. But once you're on the surface of Mars, same problem, because no magnetic field, not much atmosphere, a lot of radiation. So for colonists, they're going to have a lot of protection and shielding in whatever habitat they set up.
Now, I understand that also weightlessness is a problem. All of us have seen our astronauts upside down waving at us from the International Space Station, but these astronauts are only there for a few months. If you're in a weightless or near weightless environment for 2 years at a time, there's also a problem with muscle and bone degeneration. So do you think that our astronauts are up to it, that with exercise and all sorts of different kinds of tricks, that we'll be able to have humans land on Mars, do what they have to do, come back after 2 years, and still walk?
Yeah, they'll be in trouble when they come back. They'll be like little babies. So weightlessness, yes, for multiple years. I mean, I think the record is close to 3 years in orbit by a Russian. And the NASA astronauts, like one of the Kelly brothers that was a year up there, more than a year, I mean, he had significant medical problems. Your eye distorts and changes in very uncomfortable ways. There are a lot of internal organs that suffer a bit. So I don't know if these are recoverable yet. We haven't got enough experiments. Mars has a third the gravity of the Earth, so it's not as bad as weightlessness, and physiologists think that with proper exercise regimens and suitably designed equipment, you can mitigate against muscle loss and bone loss and so on. So they're hoping, they're guessing that Mars won't be too bad, not as bad as being weightless for sure.
Welcome back to Science Fantastic with Professor Michio Kaku. Today, let's talk about space as it is with Professor Chris MP, distinguished professor at the University of Arizona, author of a number of great books, including Beyond, Our Future in Space, and How It Began and How It Ends. Now, I understand that, yes, space is radioactive, so radioactive that when subatomic particles go through your eyeball, you can see flashes of light as ionization trails are left inside your eyeball. And some people think that maybe explains some of the UFO sightings that our astronauts have experienced. So, as our astronauts go through the Van Allen radiation belt, there's a whole new dimension, right? They have to have extra shielding. They have to take extra precautions against radiation, right?
That's right. And they're still taking a risk. I mean, the chance of mutations and cell interactions are significant, and that could cause health problems downstream.
Okay, now let's talk about reality as it exists today. We had the SpaceX astronauts come back from outer space. It was a historic mission. Of course, we've been there, we've done that, but this was a joint private-public partnership at a fraction of the cost of a normal shuttle launch. Normal shuttle launches cost almost $1 billion per launch. That is billion with a B, $1 billion per space shuttle launch. And Elon Musk claims that he can do it for a fraction of that cost. So some people say we're entering a new era of space travel. Private-public cooperation, billionaires opening up their checkbooks, reusable rockets. So what do you think? Are we entering a new era of space exploration?
Oh, yes, definitely. I mean, the successes of SpaceX are really really profound. And people forget that SpaceX was in a competition with Boeing to do this, to get American astronauts to the space station for the first time in over a decade. And Boeing had a problem. They had a real problem with their test flight, and they're pushed off into 2021. So the big aerospace company is doing worse than the little startup SpaceX. And also, a little quieter, but also impressive, is Blue Origin. That's Jeff Bezos' company, the Amazon CEO. And they have also impressive technology and rockets that are designed to take people into orbit and beyond.
Now, some people say that rockets that are reusable is a game changer. I mean, after all, you don't junk your car after just one trip, but we junk our rockets after one trip, making space travel very expensive. About $10,000 to put a pound of anything in near-Earth orbit. That's roughly your weight in gold. So it's really expensive to get up there, but some people think that reusable rockets are a game changer. What are your thoughts?
Yes, and there's a graph that people are plotting of how the cost per pound or kilo to Earth orbit has changed over the years, and Elon Musk's technologies alone have reduced that cost by an order of magnitude in a decade, and he thinks he can get another order of magnitude, so down to $1,000 a kilo or less, a pound or less. And so, yeah, that is a game changer because it opens up a commercial market for tourism, for recreation, not just sending astronauts, but sending families into Earth orbit for holidays on hotels attached to the space station or all sorts of things.
And also the rocket that sent our astronauts back into outer space had an escape module. That is, they had an escape plan. Now, of course, we've lost 14 brave astronauts with the space shuttle with 2 explosions, very unfortunate, very tragic. But this is also great, right? I mean, an escape module so our astronauts can hit the panic button and safely come back to Earth. What are your thoughts?
Yeah, it is important. I mean, the space shuttle was reusable, but of course one shuttle was lost on launch and the other was lost on a landing. And I remember going to the mock-up they have of the shuttle at Kennedy Space Center, and it has an escape means, but it was really implausible to ever use it.
Back to Science Fantastic with Professor Michio Kaku. Once again, we have with us, astronomer Chris MP, Distinguished Professor at the University of Arizona in Tucson, author of the book Beyond, Our Future in Space. Now, Chris, we've also had Dr. Robert Zubrin of the Mars Society on our airwaves, and he claims that the real goal is not just to go to Mars, but to terraform Mars. And he claims that if you can somehow raise the temperature of Mars a few degrees, maybe 6 degrees, then you would set off a greenhouse chain reaction, and it would take off all by itself. That is, Mars would basically terraform itself if you could raise the temperature of Mars by a few degrees. So what are your thoughts? I mean, Elon Musk even thought that we should detonate hydrogen bombs on the polar ice caps to jumpstart the terraforming of Mars. But, well, that's his proposal.
Right.
But what are your thoughts about terraforming Mars? Is that out of the question?
I mean, changing a whole planet to be livable for us is a huge undertaking. Zubrin is right that, it's a modest temperature change to start liberating enough carbon dioxide that's frozen to cause a runaway greenhouse effect. But it takes place slowly. The trouble is that to raise the entire surface of a planet by even that small number of degrees takes an enormous amount of energy if you do the math. And Musk is right that, one of the few ways you can deposit enough prodigious energy into Mars to cause that heating is with bombs. And most people don't like that idea. But Musk is right that it takes something pretty dramatic to heat the planet by that amount. So that's the challenge. How do you do that amount of heating, which doesn't sound like much, but remember, it's the whole planet that you have to do that for, and you have to somehow deliver a technology to do it from the Earth, which is expensive. So I think the terraforming idea is there in principle. There's no showstoppers to it. It's not impossible technology, but it's very challenging and very expensive, and it will take a long time.
Now, some people say that maybe we can have solar satellites orbiting Mars, such that you beam some of that solar energy in terms of microwaves down to the polar ice caps. And that, of course, requires a very strange orbit. But anyway, to beam microwave energy down to the polar ice caps to begin the process of melting the ice cap so that water will freely flow on the surface of Mars. But what are your thoughts about using sunlight, that is concentrated sunlight, beamed down to the ice caps of Mars?
Yes, there are technologies to do that too. So you can put orbiting fleets of satellites around Mars that are made of sort of large Fresnel lenses, but that's very gossamer thin and very light material that will concentrate the sunlight into particular geographical areas and achieve that amount of heating and liberate the CO2 from the places where there's most of it. So that's another plausible mechanism, but it needs fleets of satellites and technology for the concentration of that sunlight that has never been demonstrated on Earth or in Earth orbit, so you'd probably have to show that you could do it in Earth orbit before you'd ever try it around Mars. But it's another goal. Question is there a viable mechanism? What countries are going to want to do this, or what are the investments required? Because it's an incredibly expensive undertaking when you work it through.
Okay, well, moving on from Mars, even into the orbits of Jupiter and Saturn, NASA at one point had Europa in its sights. Of course, that mission has been delayed. But Europa, a moon of Jupiter, apparently has liquid oceans, the volume of which exceeds the oceans of the planet Earth, and maybe there could be aquatic life underneath the ice caps of a moon of Jupiter called Europa. So what are your thoughts? What are your thoughts about the fact that we already know that there are liquid oceans outside the planet Earth, not on Mars, but on a moon of Jupiter, Europa? What are your thoughts?
That's right. It's an exciting place, and astrobiologists really wonder whether or not there might be life right now in the subsurface oceans of Europa. They don't really know the chemistry, and it's a very cold environment, but it doesn't mean that life couldn't exist there. So the getting there and getting through that ice pack, of course, is an incredible undertaking. So the missions that are planned for a decade from now, it takes a while to get out there, are going to do, radar and detailed imaging. They're going to try and find places where the ice pack might be thick enough for a future mission to perhaps melt through with a nuclear plant and explore the oceans. That would be very exciting. And a mission concept already exists for that. So it's going to be a multi-stage process, but yes, it could be a living moon.
Now, there's another moon out there which has gained some attention, Titan, a moon of Saturn with plenty of ethane and methane, and some of that could be used for rocket fuel. I mean, of course, there's no oxygen out there to ignite, but some people think that maybe there's a gas station in outer space called Titan that, when you combine it with oxygen, would give us rocket fuel. But what are your thoughts?
Yes, and when on Titan is fascinating for a lot of reasons. It's a moon with an atmosphere as thick as the air we're breathing and made of mostly the same thing, nitrogen, and it has liquid water. It had liquid on it. It's just not our kind of liquid. It's ethane and methane in a cold state. Also, this is the place where NASA's cutting its teeth with this helicopter technology, but it's also planning to send a helicopter to Titan in a future mission, and that's very exciting too, because that's the dragonfly that would fly around and sample these little liquids, and maybe there's some biochemistry in there. It's not ruled out that you could have a bizarre form of biochemistry with ethane and methane as its basis.
And we've actually landed on Titan, right? One of our space pros from Cassini actually landed on Titan. Of course, it didn't last very long there.
That's right. It was an amazing achievement, actually. The first time that we'd soft landed on an object that's essentially 1 billion miles from the Earth, that was the Huygens probe. The Europeans built it, and it just sent back half an hour of data before it died. Its battery died, but it was exciting.
Okay. Well, once again, Chris, thank you so much for being on Science Fantastic.
Yeah, it's great to be with you.
So once again, for Science Fantastic, this is Professor Michio Kaku.